Good morning, calculus student. So this is Mr. Chen. So I would like to talk about calculus BC stuff today. It's the slope field. So you may notice that the slope field, it's about the differential equation. So dy over dx, so that equals x plus y. And we want to find out that the instantaneous rate of change at each positions on the graph. So normally we would like to select those integer, okay, such as -2, -1, 0, 1. So by the time that we plug in those numbers, so we do have -2 plus 1 plus -1, then that'll be -3. So -2 plus 0, -2. So -2 plus 1, -1. -2 plus 2, 0. So -1 plus -1, -2. So -1 plus 0, -1. -1 plus 1, 0. -1 plus 2, 1. And 0 plus -1, then that'll be -1. So whatever the position, the slope that we find out, we just want to, set up that the slope field, the instantaneous rate of change. So at -2, -1, so -2, -1 down here, so the slope is -3. So that means going down this way. And then -2, 0, so it's -2. And then -2, 1, all the way up here, -1. As you can see that the dash here, so this one, it's a little bit tilted. So this one, you just want to move a little bit, back to the horizontal position. And then the other one, so what we found, -2, 2, so 0, that's going to be flat right up here. And then the rest of this, so -1, -1, -2, once again. -1, 0, -1. And then -1, 1. So this one is 0, flat. And then -1, 2, which is 1. So going this way. And then -0, -1, so it's -1. Okay, so you're going this way. But this one, it's less tilted. And then 0, 0, which is flat, because that's 0. And then 0, 1, so 0 plus 1, that's 1. So it goes this way. And then 0, 2, that's 2. Like that. Keep going. 1 plus -1, 0. Flat. And then 1, 0, 1. And then 1, 1, so 1 plus 1, 2. So this one, it's the slope. It's more tilted, like this. And then 1, 2, 3. Okay. And then 2, -1 down here, which is 1. And then 2, 0, 2. And then 2, 1, 3. And then 2, 2, which is 4. So this one's almost like vertical, like that, the slope view. And then what about for the other one, dy over dx equals x times y. So basically doing the same thing. So find out that the slope for each position. So -2 times -1, so we got 2. So -2 times 0, 0. -2 times 1, -2. -2 times 2, -4. -1 times -1, which is 1. And then -1 times 0, 0. -1 times 1, -1. -2, 0, 0. This one here, 0, 0. -1, 0, 1, 2. -2, 0. And then 2, 4. Again, just plot those slope. -2, -1. So -2, -1 starting right here. So the slope is +2. So going this way. -2, 0. So then that's 0. So it's flat. And then -2, 1, -2. So going back this way. And then negative 2 times 2, negative 4, going like that. And then the other one, so negative 1 comma negative 1, so which is 1. And then negative 1 times 0, 0, flat. Negative 1 times 2, negative 2. Okay, making sure that this one is right. Okay, back to negative 2, negative 1 comma negative 1, so that's 1. Negative 1 comma 0, that's 0. Negative 1 comma 1, negative 1. Negative 1 comma 2, negative 2. So let me fix this one. This one is less steeper. Okay, like that. And then 0 comma negative 1, 0. 0, 0, 0. 0, 1, it's all 0. 0, 2, it's all 0. Flat. 1 comma negative 1, down here, negative 1. And then 1 comma 0, 0. 1 comma 1, 1. And then 1 comma 2, 2. And then the rest of this, 2 comma negative 1, negative 2. 2 comma 0, 0, flat. 2 comma 1, 2. 2 comma 2, 4. Just like that. And then the rest of this, you guys can try that. So negative y over x using the same strategy. So the next one I would like to talk about, it's the selections of the slow field. So this one matched the slow field with their differential equation. So the differential equation is showing that dy over dx sine of x. So think about the integral. So try to integrate this. So this one will be considered cosine of negative. It's going to be negative cosine of x. Okay, so negative cosine of x. So that would be the pattern showing that negative cosine of x curve. So for C, so most likely, that would be for number 4. Okay, because that negative cosine, so instead of going this way, so it's the reflection over the x-axis. So try to connect this one. Okay, so negative cosine x curve. Okay, so just want to make it symmetrical here. Okay, so negative cosine of x. And then for number 7, so dy over dx, that's x. If you try to integrate it, then that'll be x squared over 2 plus c, which is considered quadratic. So the one that shows like a quadratic functions with the vertical translation, then that would be for b, quadratic. So it's just like a parabola. Okay, so for 7, that's b. And then what about the rest of this? You try to integrate it. So you might be wondering, this one is like y equals x squared over 2 minus y squared over 2. So it looks like that one is going to be the hyperbolic functions. So instead of doing like that, so let's just plot the point, like using the table. So let's say that we plug in the exact same value, x and y. So 1 minus 1, then that would be 0. 2 minus 2, that would be 0. As you can see that 0 minus 0, that's 0 here. 1 minus 1, that's 0. So the slope is 0, flat. And then 2 minus 2, 0, it's all 0. So for 5, then that would be D. And then for number 6, and the reason why it's for A, because that if you plug in a number, so let's say y equals 2, so 2 minus 2, it's always 0, 0, 0, 0. It's all 0 here. And then 2 minus 1, which is 1. It's always a consistent slope for each level. So for this one, number 6, it's A. And now let's take a look at that, the complicated one. So like this one right here, number 8. Again, you try to integrate it, so it's going to be like a quadratic function. Okay, so it's going to be like a quadratic. So this one somehow it shows like a pattern of quadratic. So the pattern shows that's a quadratic, so most likely it's going to be B. And then for number 9, so this one there's a way to integrate it. We can certainly do that. But again, it would just plug in a number. So let's say that y equals 0. So 0.5 times 0, then that'd be 0. So for the y value here, so it's all 0. Okay, so this one looks like, or it could be this one right here. And now let's plug in something else. So let's say y equals 2. So 1/2 times 2, then that'll be 1. Okay, so the slope would be 1. Multiplied by negative 2, then the slope would be negative. So y is positive, the slope would be positive. Y it's negative, the slope would be negative. So most likely, then that'll be for C. And then for this one here, so negative x over y, again, plug in a number. So let's say that negative 1. So let's plug in 1 and 1. So 1 over 1, that's 1, but it's negative. So if the slope is negative, so it looks like it's going to be negative right here. And then if we plug in one number is negative, the other one is positive, then the slope is going to be positive. So over here, all this, the slope, it's negative. Over here, the slope is all negative. And also over here, the slope is negative. Yeah, that's right, the slope is negative. Over here, the slope is positive. So most likely, for number 10, it's going to be the equation of a circle. There's a way to integrate it. It's by separating the variable. We haven't gone over that yet, but we will get in touch bases with the integration, separating the variable. And then, okay, so for the last one, 11. So again, plug in a number. So 1 plus 1, then we'll get 2. So 1 comma 1, the slope is 2. So 1 plus 2, then the slope would be what? 3. Okay, like that. And then let's plug in the negative number. Negative 1 plus negative 1, then that'll be negative 2. So negative 1, negative 1, so the slope is negative 2. And then what about if I plug in negative 1, 0? So the slope is always negative 1. Negative 2, 1, so the slope is also negative 1. So you see that all over here, the slope is all negative 1. So for number 11, then that'll be A. So this one you need to plug in a number. Sometimes you have to check that. Sometimes you can basically just integrate it directly to find out the pattern of the original function. And then the rest of that, so this one is given with the original function. So you want to match out with that the pattern. So this one looks like it's considered kind of like a natural log function. So if that's natural log, then that'll be E. And then this one here, kind of like a cubic functions or the tangent curve, but there's no tangent here. So most likely it's a cubic function. So again, if you just take the derivative of that, so y prime, then that would be considered 3 times 1/6, which is 1/2 times x squared. So plug in a number, x equals 0, so it's all 0. X equals 1, so the slope is always what? 1/2. And then x equals negative 1, the slope is also considered 1/2. And then x equals 4, x equals 2, so 2 squared, then that'd be 4 times 1/2, 2. So at 2, the slope is all 2. And then at 4, so the slope is going to be like, very straight, okay, very deep. So 4 squared, 16, 16 times 1/2, 8. It's all that. Same thing happened over here. So this one for 13, so then that'll be D. And then what about this one, matching? Okay, so it looks like this one is kind of like an upside down parabola. Okay, so let's just make sure that it could be like a cosine curve as well. But for the cosine curve, it shows like the turning point, but this one is all like a concave down. If that's concave down, most likely it's C. And then this one here is quite similar to one of the problems that we did previously. So it looks like it's a sideway quadratic functions. So it's like a sideway parabola. So this one, again, take the derivative. So we got 1 equals 2y times y prime implicitly. Solve for y prime. So we got 1 over 2y equals y prime. So again, plug in a number if y equals 1. So what happens if y equals 1? The slope it's always 1/2. If y it's considered -1, then the slope it's -1/2. So y equals 0, the slope is what? Undefined. That's why it's not showing on the x-axis. So y is positive, the slope is positive. Okay, so if y is being negative, then the slope will be negative. Okay, so this one you want to solve for y prime. So most likely, the answer would be D. Okay, so thank you for watching the video today. So in case that you do have any questions, so please let me know. Okay, so see you guys next time. Take care.